Hey everyone, and welcome back to Cosmic Origins Revealed. So look up for a second. When you see the Milky Way, that big, luminous river of stars, well, I gotta tell you, that light, it's kind of a lie. It's the 4% we can see. The rest, the vast, overwhelming majority of our universe, it's utterly invisible. It's dark everything. Right now, we're focusing on something invisible inside the invisible. Something is radiating from the galactic center, an energy signature we honestly can't explain. A perfectly symmetrical, ghostly glow of gamma rays. I mean, it's the whisper of an untold story. If we can confirm what this energy is, I think the story of the universe changes forever. Really. Okay, so our galactic core, it's not a chill place. It's like a cosmic metropolis. You've got the supermassive black hole, Sagittarius A*. You have millions of stars packed literally shoulder to shoulder. You have colliding gas clouds. This whole mess naturally produces gamma rays, the highest energy light. They're basically born from high-speed particle collisions, like cosmic rays smashing into gas. For years, astronomers have known about an anomaly here, the infamous Galactic Center Excess, or GCE. It was this localized gamma-ray hotspot that was simply too bright to be explained by all the known physics of the region. It didn't look like pulsars. It didn't look like regular gas clouds. It looked, I don't know, manufactured. It was a huge clue, but one we couldn't quite decode, Why do we care about this specific region? Well, basically, the galactic core is where dark matter is theorized to be at its absolute highest density. Now, the new investigation. This time, a team at Johns Hopkins in October 2025 didn't just look at that original GCE hotspot. They mapped the entire inner galaxy's diffuse gamma-ray background with, crazy precision. The method, honestly, was super systematic and surgical. They took the raw data from the Fermi Gamma-Ray Space Telescope, and they started eliminating known culprits one by one. They meticulously subtracted the light from all known pulsars. Then, they modeled and removed the high-energy light produced by cosmic rays hitting molecular gas. They literally cleaned the slate. They filtered out the noise of conventional astrophysics, right? And what remained was not noise. It was this unmistakable, distinct signature. A symmetrical, spherical halo of gamma-ray energy centered precisely on the galactic core. It wasn't messy. It wasn't clustered. It just wrapped around the core like a perfect, theoretical sphere. The analysis was statistically robust. Whatever was causing this glow was not standard astrophysics. The glow was completely inexplicable, unless, of course, you introduce a completely new particle. Wow! So let's talk about dark matter, because we've got to simplify the physics here. We know it exists because of its giant gravitational pull on galaxies, but we don't know what it is. The leading theoretical candidate is the WIMP, the weakly interacting massive particle. Now, WIMPs are their own antiparticles, and here's the key part. If two WIMP particles collide, they can annihilate. This isn't just a simple bump, it's like a tiny explosion. Two particles convert their entire mass directly into pure energy, and the result is a burst of high-energy particles, including, gamma rays. It's cosmic self-destruction, essentially. Since dark matter is densest at the center of the galaxy, WIMP annihilation should be most frequent there, creating that vast spherical gamma-ray halo. Crucially, the exact energy profile of the mysterious glow detected by the Johns Hopkins team perfectly matches the theoretical energy output of those WIMP annihilation models. I mean, it is the signature we've been hunting for, the physical echo of dark matter destroying itself.
Okay, but science doesn't just hand out the Nobel Prize for a perfect fit. Every single alternative must be rigorously eliminated. The main rival explanation is the existence of unresolved pulsars. Pulsars, those fast-spinning neutron stars, are brilliant gamma-ray emitters. Skeptics argue that the galactic core is simply packed with tens of thousands of dim pulsars that are just too faint for our telescopes to see individually. If they exist in sufficient numbers, I suppose their combined light could kind of mimic a smooth, diffuse glow. But the data, it pushes back. The gamma-ray halo is too smooth and too symmetrical to be a cluster of astrophysical point sources. Pulsars are stars. They are generally constrained to the messy, turbulent, disk-like plane of the galaxy. This mysterious glow, however, is a perfect sphere wrapping around the core, extending way above the galactic plane. Exactly the distribution that a gravitationally dominant dark matter halo would take. It's a structure that perfectly obeys gravity, not the messiness of stellar formation. This is where the tension really explodes. The data points toward a world-changing conclusion, but the stakes are just too high for anyone to jump to consensus. It's basically an astronomical Cold War between two smart, passionate camps. On one side, the particle physicists armed with this new analysis are pretty confident. Johns Hopkins lead Dr. Elena Rodriguez stated the data shows a statistically significant deviation from every known astrophysical model. We have to follow the data where it leads, and right now it points toward a new particle. On the other, the astrophysicists argue for patience, pointing out the limitations of our current maps. Dr. Kenji Tanaka, a pulsar expert, counters, "We are still improving our models for the inner galaxy. To claim dark matter from this is premature. It just means our current pulsar census is incomplete." It's a fierce debate. Is this the first true glimpse of a brand new fundamental particle? Or simply, the inadequacy of our current tools? So why does this matter, right? If this gamma-ray glow is WIMP annihilation, it doesn't just solve one mystery, it potentially solves three of the biggest challenges in modern physics. One, it confirms the nature of dark matter. It gives us a particle and proves that it interacts with itself. Two, it connects the cosmic scale of the universe, like galaxy formation, to the quantum scale of particle physics. It forces us to literally rewrite the standard model of physics to include a brand new fundamental particle. Three, it tells us the mass of the dark matter particle, giving us a concrete target for all those giant underground detectors trying to catch a dark matter particle directly. This isn't just a discovery, it's a cosmic Rosetta Stone. It would be a paradigm shift, the biggest breakthrough since the discovery of the accelerating universe. The hunt for dark matter has always been a search for the invisible, the undetectable. Now we might be staring directly at the light created by its destruction. It's an open case, sure, but the evidence is mounting. The symmetry is just too perfect, and the energy signature is too compelling to ignore. If this mysterious glow is truly the echo of dark matter self-annihilating, it doesn't just change physics, it changes everything we thought we knew about the universe. What do you guys think? Is it dark matter or just weird pulsars? Let me know in the comments below. And if you want to keep exploring the deep questions of our cosmos, smash that like button, subscribe to Cosmic Origins Revealed, and check out all the study links in the description. Until next time, keep those origins revealed.